Exercise 5C, question 1A, part 2. All I've done so far is written down the given equation. The substitution we'll be using, which is y equals vx. I've then differentiated that using the product rule, and then just for convenience I've rearranged it to say that y over x equals v. So the next stage is just to substitute everything in, and you should see that I end up with this differential equation, which I can now simplify to give me this. Clearly I can separate the variables here, and furthermore I can see that v squared minus 5v is going into a denominator, and straight away I realise I'm going to be using partial fractions, so I've set everything up ready for that to happen. So I've factorised the denominator on the left hand side as v parenthesis v minus 5. So we need to break this up, and we'll break it up as shown, a over v plus b over v minus 5. There's a very quick way of finding those. I've decided to show the method this time, so multiplying throughout by the denominator on the left will lead to this situation. The easy way to find the values now is first of all just to say if v is equal to 5, then the term a parenthesis v minus 5 will essentially be 0, and that will give me that b is a fifth, and also likewise if I set v equal to 0 I'll get a is minus 1/5. So just make sure you can understand how I've got those two values. Right, let's rewrite the original differential equation as shown. I just pulled a factor of a fifth out to the beginning, and then I've just integrated directly, and after integrating I move that 5 across to the other side just for convenience. So make sure you're happy with this. Right, what I've tried to do for the rest of the problem is simply end up with the answer in the back of the book so that you can check each stage of the working. In reality there are some rather more elegant ways of dealing with this, but if I just proceed on, so using the law of logarithms on the left hand side gives me this. I've then substituted the v's out again with y over x to give me this. Fairly clearly I can manipulate the left hand side, which I've now done. Make sure you understand how I've done that. Essentially, well, I made the numerator as 5x minus y all over x, and then I can multiply by the reciprocal of the denominator however you want to see that. But nonetheless we end up with this result. And then I've brought the fifth back across to the left hand side just to be consistent with the book, and I've rewritten, rather than 5x minus y, I wrote it as 5 minus yx. Y minus 5x, yeah. And I can do that of course because it's the modulus that we're actually taking there. And then I just changed the constant to be plus k. Y, well, I divided throughout by 5, so it could have been c over 5. It doesn't really matter, just plus a constant. And that's it.